In this video's lesson, we're going to talk all about how we can use describing quantitative data with a new measure of spread called standard deviation. While this might be one of the hardest calculations to do, it's probably one of the most valuable that we can do because it gives us an idea of how far spread apart the values are from the mean. So just to give you an idea of kind of what that looks like, if you're looking at this, say, this dot plot that I've got for us, so you've got a point here at 1, 2 dots at 2, 1 at 3, 1 at 5, 2 at 6, and 1 at 7. If you add all those up, divide by how many there are, you end up finding that the mean is right here at 4. And so then what we might want to do is figure out kind of how far away are those from our mean on average. Well, this dot plot at 1 is 3 away from the mean. Both of these points at 2 are going to be 2 away from the mean, and 3 is going to be 1 away from the mean. Likewise, 5 is 1 away from the mean. Both points at 6 are 2 away from the mean, and that point at 7 is 3 away from the mean. So here's what you can do. If you add all those up and divide by how many there are, you find out that the average distance from the mean in this case is actually exactly equal to 2. And so we would say that the standard deviation, which we write as S sub x, is going to be equal to 2. So let's talk about the formula for standard deviation as well as for variance and kind of what the difference is between those. So for standard deviation, we typically use the notation S with an X as the subscript, meaning it's written below S to the right. Whereas for variance, we write out VAR for variance, and in parentheses, we put X to say the variable that we're finding the variance of. So standard deviation is the average distance each of the points is from the mean. So the average distance from the mean is how you want to think about standard deviation. Variance, on the other hand, is the average distance between the points. So if you're wanting to just know how far away are the points from each other on average, that's going to be where variance comes into play. We're first going to talk about the formula for variance, and then we'll see how it compares to the formula for standard deviation. So your formula for variance, the variance of your variable x, is going to be equal to taking 1 divided by n minus 1, where n represents the number of terms, multiplied by the sum of all of your data values, x sub I, minus your mean, x bar, squared. Now again, we're going to work through some examples, so if it doesn't quite make sense what that calculation is going to do, that's okay. It actually turns out that standard deviation is just the square root of your variance. So if you find the variance first, just take the square root, and that will be your standard deviation. Or you could write it all the way out using the formula. So that would be the square root of 1 over n minus 1 multiplied by the sum of x sub I minus x bar squared. So before we calculate it, let's just talk about how it's related to the range, the interquartile range, and standard deviation itself. So when you're talking about all three of those, range, interquartile range, and standard deviation, let's first talk the similarities. And probably the big similarity is that they are all measures of spread. In other words, they tell you how far apart your data is. But really, that's about it. Most of the rest are in terms of differences. And there's kind of one key difference that I want to kind of point out, is that the range and standard deviation are not resistant. So these are not resistant measures of spread, and so that's going to be kind of something we'll have to watch out for, especially if there are outliers in the data set. The interquartile range, remember, is resistant. So if we do have outliers or if our data is skewed, that'll typically be our measure that we want to use. So what are some properties of standard deviation? Well, first off, it's always going to be a positive number. And the reason for that is, remember that the definition says it was the average distance from the mean. So whenever we think distances, we're going to have to kind of always think about those as being positive numbers. Some other things to kind of mention to you. The larger the standard deviation, the more spread out the data is. Whereas the smaller the standard deviation, the less spread out it is. Also, we already mentioned, but it is not a resistant measure, so it is affected by outliers. And I think that's all I want to share with you right now. Let's go ahead and find the standard deviation for a data set. So here I have a random sample of 5 students who were asked about how many minutes they spent during doing homework the previous night. Their responses in minutes were as follows. They spent either 0, 25, 30, 60, or 90 minutes. And it wants us to calculate and interpret, so we have 2 parts, the standard deviation first by hand. Then we'll go ahead and find the standard deviation using the graphing calculator. So this might be the only time we actually do it by hand. And I just wanted to show you how the formula works. You'll have your graphing calculator, though, to do most of the rest of the work for you. Okay, so in order to calculate standard deviation, the first thing we're going to want to think about is finding x bar. So in other words, we want to find the mean for our data set. So if you add those values up, so 0 plus 25 plus 30 plus 60 plus 90, those total to be 205. And there were 5 students total, so divide by 5, and we'll find out that the average for this data set was 41. The next thing we'll want to do is remember that our n, so our number in the sample, is equal to 5. So when we put those into our formula, let's go ahead and do variance first, and then we'll use it to find standard deviation. So for variance, we're going to start by taking 1 divided by n minus 1, so 1 divided by 5 minus 1. Now, where it said the sum of, so in our formula, this Greek letter for sigma means the sum. That basically means we're going to add up a whole bunch of stuff related to x sub I minus x bar. What that means, x sub I is your observation from the sample. So that would be 0 minus x bar we found was 41. We'll close our parentheses and square it. So that's what it means when it says x sub I minus x bar. It means take the value from your sample minus your mean and square it. Now here's where the sigma comes in, is that you're now going to add to that the next one. So the next value in the data set was 25. So we'll take 25 minus 41 and square it. And then we'll do that again. So we'll take 30 minus 41 and square it, plus 60 minus 41 and square it, plus 90 minus 41 and square it. All right, so first let's go ahead and simplify. 1 over 5 minus 1 would be 1 over 4. And then be careful with typing that into your calculator. Let's go ahead and type that in. So we'll start with our parentheses, 0 minus 41 and square it, plus our next one was 25 minus 41 and square it, plus 30 minus 41 and square it, plus 60 minus 41 and square it, plus 90 minus 41 and square it. So once we've got all that typed in, we come up with this value, which is 4,820. So then if you take that and divide by 4, or multiply by 1/4, either way you should get the same answer, which is 1,205. So there's our variance. We now want to find our standard deviation. So for standard deviation, remember you take the square root of variance. And so that would be the square root of 1,205, which when you take the square root of that answer that we just got, so square root of our answer, we'll get 34.71. So there's our standard deviation. So that was the calculate part. It also wanted us to interpret the standard deviation. So we would say, on average, the data points were 34.71 minutes, because we were looking at how many minutes they spent on homework. So 34.71 minutes away from the mean. Now, looking at our data, remember 41 was our mean. Some of them were more than 34 away from our mean, like 0 or 90. Some were less than 34 away from our mean, so 30 and 25 and 60. None of them were exactly 34.71 minutes away from the mean. And that's okay. We're just saying that on average, each of our data points was about 34 minutes or 35 minutes away from our mean, which was 41. Let's now go ahead and find that using our graphing calculator. So the way that we will do that, we'll first go into our stat menu and choose edit. Again, if you have data in there from previous problems, go ahead and clear that by going up to the list name and pressing clear. We'll do that for both of these lists. And then we'll go ahead and type in our data. So that was 0, 25, 30, 60, and 90. Once we've got all that data in there, we'll go ahead and quit from this screen. We'll go back into Stat, over to Calc, and that option that we used in the previous section of the notes, one var stats, where we were able to find all that information like the mean and median and so on. We're going to go ahead and make sure that that list is the correct list, so list 1, and then we'll go ahead and press Calculate. It will again tell us what we already knew, which was that the mean was 41. In addition to that, if you notice where it says S sub x, it does in fact tell us that that was 34.71, which was the same thing that we got using the formula from above. Now, it also gives us another one, which is sigma sub x, and tells us that that is 31.04. Please know that we are going to be using this standard deviation right here. This one, just as a side note, is for population standard deviation. So if you ever wanted to talk about a population standard deviation, you would actually use this 31.04. It has a similar formula, but there's kind of one big difference. Instead of taking 1 over n minus 1, you just take 1 over n instead. But we're going to go ahead and use the one that I've starred, which is for a sample standard deviation, unless we run into a set of data where it gave us information about the population. All right, that's all I've got for us in this video. In the next video, we will just be doing some additional practice with using your graphing calculator to determine the median, mean, and other parts of the summary statistics for a set of data. Until then, have a great rest of your day.